Welcome to the Foundations of Software Architecture. Before we look at any specific pattern or style, we need to answer the most fundamental question: what actually is software architecture, and why should you, as an engineer who can already build working software, care about it at all? Most developers have lived this. You start with something small and clean, then 6 months later, a change to the payment logic somehow breaks the login page. Modules that were never meant to talk are tightly tangled together. At that point, every new feature carries hidden risk, and the cost of change compounds with every sprint. This is the pain that software architecture exists to prevent. Think about a building. An architect decides upfront where the load-bearing walls go, where the plumbing runs, and how the floors connect. A painter can change the colors anytime, but nobody wants to move a structural wall after the building is finished. Software is identical. Low-level details, variable names, helper functions, UI polish are the paint. The structure underneath is the load-bearing wall, and that is what architecture governs. Software architecture answers 3 questions about a system. First, what are the major components, the meaningful chunks of the system, like a user-facing service, a database, or a background worker? Second, what is each component responsible for? What does it own and what must it never do? Third, how do those components interact, through direct calls, message queues, or shared data? Together, these 3 answers define the system structure. Here is how an architectural decision actually shapes a system over time. A significant question arises, say, where should business rules live? A decision is made. Put them in a dedicated logic layer. That choice forces clear component boundaries. Each component gets defined interactions with the others. The consequence is that future changes stay contained. You can replace the database without touching the user interface, because the layers only know about the layer directly next to them. There is a real trade-off here. Investing time in architecture upfront slows you down at the very start. That is a genuine cost. But without it, the system accrues structural debt. Each new feature is harder than the last. Each bug fix risks a regression, and eventually the team spends more time managing complexity than building value. The upfront cost of good architecture is almost always smaller than the long-term cost of ignoring it. Thinking architecturally is a habit, not a one-time ceremony. The key question to always ask is, how hard would it be to change this decision in 6 months? If the answer is very hard, that decision is architectural and deserves deliberate thought. Write down your components, their responsibilities, and their interaction rules, even informally. Keeping that picture explicit is what separates a system that stays changeable from one that slowly freezes. Let us bring it together. Software architecture is the collection of significant, hard-to-change decisions that define a system's structure. What the components are, what each one is responsible for, and how they interact. It is distinct from implementation detail precisely because changing it later is costly. The whole point of investing in it early is to keep future change cheap, safe, and predictable. That principle runs through every pattern and style we will study in this course.